Here we have an object moving along a curved path. You can imagine this as being in a car driving along a windy road and the light beam is your headlights. If you were to stop at this moment along the curve, your headlights are pointed in the direction of the arrow, and this is also your instantaneous velocity at this moment. If you continue around the curve and stop at this point, now the green arrow represents your instantaneous velocity at this exact instant. We know that the acceleration is the change in velocity over a change in time. So if we take these two velocity vectors and subtract them from each other, we will get an acceleration vector. This is shown here with v denoting velocity and a denoting acceleration. If we move our acceleration vector to a point along the curve between the time of the first velocity and the time of the second velocity, we will get the direction of acceleration along the curve. As you can see here, the direction of acceleration points to the inside of the curved path. If you continue down this path, you will come to another spot in the road where there is another curved path. At this point is again your first instantaneous velocity, and if we continue around the curve, we come to another point of instantaneous velocity. And again, if we subtract these vectors from each other, we will come up with now another acceleration vector. Again, if we move this acceleration vector to a point along the path between the time of the first velocity vector and the second velocity vector, we will now see that the acceleration vector is once again pointing towards the inside of the curve. From this video, we note that acceleration along a curved path always points towards the center of the curve, and we can also note that acceleration is not always in the direction of velocity.